Good afternoon. Today we are working on CO49. I can graph a function using a function table. Remember that in a function table, each pair of x and y values represent an ordered pair. You can graph a function using a function table by plotting each ordered pair on a coordinate plane and connecting them with a line. So we're going to look at our coordinate or our function table, and we're going to figure out what each ordered pair would be. Then we need to write a rule for the table. So that's going to put a little bit more thought into it. So looking at it and saying, oh, x, y, I know that the x comes first and then the y. That's an easy ordered pair for me to write. I need to do all of my ordered pairs. So the x, then the y, it's alphabetical, it's always x, then y. So you're gonna wanna write your ordered pairs. This is the big one. Now I need to figure out what my rule would be. Y equals what? To get to my y, what am I doing to my x? Paul? Every x, I'm adding 2 to it. So -2 goes to 0, 0 goes to 2, 2 goes to 4, 3 goes to 5. So I have my x plus 2. That's going to be my rule. What do I do to the x to get to the 2, or to get to the y? Then I have to graph my function. So I'm going to take my 4 ordered pairs and I'm going to graph them. -2, 0. Right on the line there. 0, 2. 2, 4. And 3, 5. So if I take a ruler and draw a nice straight line, it's going to look like that. So graphing your function is plotting your ordered pairs and drawing the line to connect them. Now it says list an ordered pair not included in the table, but will be on the line. Now this is a line, not a segment, so I'm going to do that. Who can tell me how I would find an ordered pair that would be on the line, but isn't written already? How could I do that, Chase?
You could add 1 to y and x, because it's 2 above it, so it's 2 above x.
So I can pick an x that's not listed. So Chase is like, oh, 1 isn't listed on here, so I could pick a 1. I'm going to put it into my rule. 1 plus 2 equals 3. So a new ordered pair could be 1, 3. So pick an x that we don't have listed, put it into your rule, and find the y, and then you can make your ordered pair. Paul?
Some of these are listed in the wrong way, because when I'm doing -3 to the next one, plotting it, it's on the 0, then it skips to 1, but it's not actually 1 it's supposed to be. Well, when you're
What's our rule here? If we look at our next one, what would the rule be? Y equals x plus 1, because we look at our x, we're increasing it by 1 every time we go from the x to the y. So if we're going to do our ordered pairs, we would have -3, -2, -1, 0. So did you write out your ordered pairs, Paul?
No, I have them, but for the first one, it's
Where would it be on the graph?
on the 2.
-3 to -2. So I'm going to come out to -3 and I'm going to go down to -2.
Oh, I see what I did wrong.
Okay, so we have to be careful how we're graphing everything. So then we have -1, 0, 0, 1, 2, 3. So one way, what Paul did was he realized a mistake he made because it didn't make sense. He said, I was trying to graph that next one and it doesn't seem right. Something's wrong. That's when you go back and you make sure that you're graphing the ordered pairs correctly. And he was able to find his mistake. If we had one that was up here, we can see, oh, that's not following in our line. So be careful. Your way of checking to see if you are graphing it correctly is to see, is it making that straight line? Does it go wonky on me? Well, then I probably made a mistake if my graphic went wonky. The big thing to figure out is what the rule is. How do I go from my X to the Y? It's not always going to be adding or subtracting. It's algebra. We have multiplying and dividing also. So if they're not all increasing, we have 4 different inputs into our function table. We have 4, so we can find that pattern. How do we go from the X to the Y? If we only looked at 2, we might think something is adding, when in reality, we're multiplying. So be careful as you move on to the next page, really looking, am I adding, subtracting, multiplying, or dividing, going from the X to the Y? Then you need to write your ordered pairs. What's the last thing I have to do in example number 2 here? Ethan? List an ordered pair that's not already written down. What could I do? Paisley?
1 and 2.
So if I have 1 for my X, if I put, because there isn't a 1 listed in my function table, if I put 1 in for my table, in my rule, 1 plus 1 would give me 2. So that's a simple, easy ordered pair. So we're not trying to make this overly complicated. You don't need to pick 252 for your X. Would 252, could that be on our line? Sure, sure can. What would the Y be if we did 252? Colin? 253, because this is a line. We have our arrows. Our function doesn't say less than or equal to, less than, greater than, right? It's a line, so it can go on and on. It could be big numbers, but we don't need to overcomplicate our lives. Keep it simple. Do we have any questions on graphing our function table? Okay, while you're working, I'm going to be calling people up. For my friends that are listening at home, we hope you are well.